November 26, 1926, Herstal, Belgium, inside the FN factory. At a workbench sat John Moses Browning, widely regarded as the greatest firearms designer the world had ever seen. He collapsed at his bench and died. He was 71. On the table before him lay an unfinished pistol, only partly completed, a work in progress. It held the promise of something unprecedented, a service handgun with double the ammunition capacity of most contemporaries. Where the standard military pistols of the era commonly held 7 or 8 rounds, this design would accept 13. Its mechanism promised simplicity, the form promised lighter weight, and if anyone could take Browning's fragmentary notes and complete the job, the result would redefine what an Army sidearm could be. There was, however, a problem. Browning had kept much of the design locked in his head. Detailed production drawings did not exist for every aspect. After his death, the pistol's future depended on other engineers' ability to capture and finish his concept. 14 years later, German armor rolled into Belgium and seized the FN works. Inside, they found the completed pistol, the high power, and soon put it into Wehrmacht production. Over the next 4 years of occupation, FN would churn out more than 300,000 of these pistols for Nazi Germany. Meanwhile, in England, a man who had helped translate Browning's idea into reality was racing to reconstruct production drawings from memory so Allied factories could make their own examples. This is the story of how a partially finished design by a dead American became the 20th century's most influential combat pistol, how it ended up arming both sides in the same conflict, why Britain's special forces prized it even as regular army procurement clung to revolvers, and why the pistol's legacy still shapes modern sidearms. The saga begins with France. In 1921, the French military issued requirements for a new service pistol that were surprisingly ambitious. They wanted a handgun holding at least 10 rounds in a caliber of 9mm or larger, effective at 50 meters, and weighing under 1 kilogram. At that time, no existing service pistol met those demands. The Colt 1911 carried 7 rounds, the Luger 8, and British officers still routinely carried 6-shot Webley revolvers. The French requirement implicitly demanded a leap, double the capacity of some current service arms within the same ergonomic envelope. John Browning, working from Ogden, Utah, saw opportunity. He had designed the Colt 1911 earlier, but had sold patent rights and could not simply reuse that design wholesale, so he started fresh. The key breakthrough, however, did not come solely from him. A Belgian engineer at Fabrique Nationale, John, sometimes written as John Browning's colleague in spirit but technical partner in execution, was Marcel, or rather Dieudonné Save, often anglicized as John or Juden Save in wartime accounts, and he contributed a crucial innovation, a practical double-column or double-stack magazine for a service pistol. The idea seems obvious today, but at the time, building a reliable military-grade pistol that accepted staggered rounds in 2 columns and then fused them into a single feed at the top was an unproven engineering challenge. Save's magazine geometry allowed Browning's initial concept to nearly double the ammunition carried without making the grip uncomfortably large. A single-stack 38 or 9mm magazine typically fits 7 or 8 cartridges in a grip sized for military service. The staggered approach squeezed 13 rounds into a grip only marginally wider, meeting the French specification on capacity while keeping the pistol manageable in hand. The finished pistol's empty weight hovered around 900 grams, close to the French target, with an overall length near 200 millimeters. Muzzle velocities depended on the ammunition, but generally fell into the mid-300 meters per second range. Browning filed a patent on June 28, 1923, and constructed prototypes, traveling to Belgium repeatedly to refine the design at FN. Over the next few years, he solved feeding issues, honed the trigger mechanism, and refined other details, but he died before he could see the pistol through to final production. After his death, Save spent roughly 8 years finishing the work. When Colt's patents on earlier Browning concepts expired in 1928, some techniques that had been legally restricted became available.
Sive replaced Browning's swinging link barrel locking, as used on the 1911, with a shaped cam that simplified manufacturing and improved reliability under field conditions. The finalized design reached readiness in 1934. FN designated it the P-35 and began production in 1935. Here comes an ironic twist. The nation that had requested the pistol, France, rejected it. Instead, Paris adopted a domestic design, the Model 1935 family, leaving the very handgun designed to French specifications without a primary patron. FN christened the pistol Browning High Power, the high power moniker referencing the increased magazine capacity rather than ballistic energy. By May 1940, FN had produced roughly 56,000 pistols, mostly destined for Belgium and for exports to China. Then Germany invaded on May 10, 1940. The FN factory fell intact 2 days later. German industrial managers immediately recognized the strategic value of the captured design and tooling and resumed production under occupation. The pistol was given a Wehrmacht catalog number, Pistole 640B, the B denoting Belgian origin. German procurement favored issuing these pistols to elite and specialized formations, Waffen-SS units, Fallschirmjäger paratroopers and the like, rather than to ordinary infantry. Occupied FN would ultimately manufacture on the order of 300,000 high powers for the German war effort over the next 4 years. As wartime pressures intensified, production shortcuts appeared. Some late-war examples lack magazine safety disconnects, and heat treatment and finishing quality declined. There are post-war stories of Belgian workers deliberately sabotaging production through improper heat treatment or other small acts of resistance, though primary source confirmation of widespread intentional sabotage is patchy. The strangest, most symbolic consequence of this dual production occurred at Arnhem in September 1944 during Operation Martin Garden. British paratroopers of the 1st Airborne Division encountered Waffen-SS troops across the Nijmegen-Arnhem corridor. Anecdotes suggest that combatants on both banks of the river may have been pointing high powers that had been manufactured in the very same Belgian factory. The same model, identical caliber, same magazine capacity, and factory origin shared by enemies facing one another in battle. That image of men on opposite sides wielding pistols born of the same workshop captures the oddities of industrial war. Save himself later fled occupied Europe in mid-1941 with help from the Belgian resistance. He escaped across Vichy France into neutral Spain, then to Portugal, and finally by ship to England. He arrived without the complete set of production drawings. Some documentation remained hidden in Belgium, and other details existed only in men's heads. At the Royal Small Arms Factory Design Department in Enfield, sometimes referenced as Chessington or Enfield's Design Department, Save and British engineers set about painstakingly reconstructing production specifications from what fragments were available, from a few pre-war pistols that had made it out, and from Save's own recollection of the dimensions he had labored to perfect for a decade. Imagine recreating industrial blueprints for a precision mechanical instrument from recollection and a handful of physical examples. That is precisely what they did. By June 1943, the British had modified Save's drawings and adapted them for local industrial methods. But British factories were already fully committed. Lee Enfield rifles, Sten submachine guns, Bren guns, and myriad other items took every lathe and milling machine and most of the skilled labor. There was little spare capacity to take on a new service pistol line. The solution came from across the Atlantic, the John Inglis Company of Toronto. Inglis had been a struggling metalworks firm in the Depression until Major James Hahn took over in 1937. Inglis won contracts for Bren production, and by 1943 was manufacturing a large share of Commonwealth Bren guns.
The factory had the precision tooling, the workforce, and the available floor space to take on pistol manufacture. In April 1943, a Chinese request entered the equation. Under Canadian mutual aid, China applied for 180,000 high powers, with tangent sights graduated to 500 meters and wooden shoulder stocks, a curious Mauser C-96 style accessory. FN agreed to license production for a modest royalty of 25 cents per pistol, payable after the war. Save and another Belgian engineer, René Lallieu, traveled to Toronto to assist with tooling and quality control. Inglis started production in February 1944, manufacturing two principal variants, the No. 1 Mark I with tangent sights and stock slot, intended for China, given a CH serial prefix, and the No. 2 Mark I fixed sights, Parkerized finish, Bakelite grips, and serials with T prefixes, destined for Commonwealth forces. The Chinese contract collapsed in September 1944, amid changing war dynamics. Only about 4,000 pistols reached China before the agreement was canceled. The remainder of the Chinese pattern pistols were redirected to British and Commonwealth units. By October 1945, Inglis had produced roughly 151,816 high powers.
Now, we must carefully examine a widely circulated claim that the French resistance specifically begged for the high power en masse and that it became their signature pistol. The documentary record is subtler. The Special Operations Executive, SOE, the British organization tasked with supporting resistance movements across occupied Europe, did request and receive tens of thousands of Inglis high powers. Contemporary records show approximately 40,000 to 50,000 were delivered to Britain in 1944 to 1945. And the evidence supports that many of those pistols were issued to SOE agents and the small, highly trained JED-B teams parachuted into France and other theaters to coordinate local resistance. Official SOE supply lists and JED-B equipment manifests show these teams carried a mixture of sidearms, Webley Mark III revolvers, Enfield No. 2 revolvers, and Inglis-manufactured Browning high powers in 9mm. Choice of pistol often depended on availability and personal preference. What the sources do not support is a romantic picture of the French marquis collectively and preferentially demanding high powers above other types. In June 1944 alone, SOE supply manifests show British aircraft dropped roughly 10,000 Sten submachine guns, with some 8 million rounds of 9mm. Over 8,000 pistols of various kinds, more than 5,000 rifles, over 5,000 M1 carbines, and more than 2,000 Bren guns. The Sten, cheap, concealable, using the same 9mm ammunition as captured German weapons, and relatively easy to clandestinely manufacture or repair, became the signature weapon associated with SOE and with resistance groups. Pistols were always a smaller part of supply drops, and many different models were sent. The image of the high power as the overwhelmingly preferred pistol of the resistance is more enthusiast myth than documentary reality. Nonetheless, the high power mattered greatly to the operatives who did carry it. For lone SOE agents operating in occupied territory, the pistol's 13-round capacity carried tactical advantages over revolvers. 2 or 3 encounters could become lethal quickly. Having double the shots before reloading might determine whether an agent escaped a compromised safe house, survived an ambush, or survived. The pistol's 9mm chambering allowed resupply from captured German ammunition stocks. German MP40s and other weapons used 9x19mm, meaning that a downed agent or an operative working with partisans could scavenge ammunition from enemy casualties or supply dumps. Compared to the U.S. .45 Colt 1911, which fired a heavier bullet with more stopping power, but only 7 rounds, the high power offered far greater sustained fire in a lighter, flatter profile package that concealed more easily under civilian dress.
For clandestine work, capacity coupled with concealability mattered. Many agents routinely cached pistols on arrival precisely because the risk of being discovered in possession of a weapon during random searches outweighed the benefits of carrying it openly. Those caches sometimes trickled into local partisan hands, a secondary, opportunistic route by which high powers found their way to Maquis units. But that was ad hoc distribution, not centrally organized requisitioning on a mass scale.
Meanwhile, the British Regular Army remained resistant to semi-automatic service pistols for reasons of institutional conservatism and doctrine. For decades, the British forces held to the view that revolvers were tougher, more reliable, and adequate for officers' sidearm roles. Indeed, the British Army was among the last major powers to officially adopt a semi-automatic service pistol, not standardizing on a modern auto until 1954, almost a decade after the war. This is not evidence the high power was thought useless. Rather, it reflects procurement inertia, ceremonial traditions, and a low priority assigned to modernizing officers' sidearms compared to rifles and automatic weapons. Special operations units, who needed compact firepower more than ceremonially tidy revolvers, adopted the high power enthusiastically. The SAS, for example, adopted the high power as its standard sidearm from the Second World War through the early 1990s. The 6th Airborne Division received large numbers of English-produced high powers by March 1945 for Operation Varsity, the massive Rhine-crossing airborne operation that deployed over 16,000 paratroopers on a single day. Commandos and other raiding units prized the high power for behind-the-lines operations. Those who needed practical combat pistols got them, while the massive standard Army formations continued to favor older sidearms until procurement policy changed. For missions where absolute deniability mattered, SOE used purpose-built, sterile weapons like suppressed Wellin or Welrod pistols manufactured without serial numbers. The high power fulfilled a different niche, a robust, high-capacity sidearm for clandestine operators who might need sustained firepower rather than stealth. Later moments in history highlighted the pistol's continued utility. In 1980, SAS television footage during the Iranian embassy siege showed operators wielding high powers, capturing public attention anew. In the Falklands conflict, both sides carried pistols of the same design family, British L9A1 variants versus Argentine-produced or licensed variants, once again illustrating how the same mechanism ended up on both sides of later fights. After the war, the high power's influence only broadened. It was adopted by more than 50 national militaries across some 93 countries and became, functionally, the global standard in service pistols in the decades that followed the 1911's influence in America. The Browning tilting barrel short recoil mechanism, coupled with Save's double-column magazine idea, became the template for modern combat pistols. Models ranging from the Beretta 92 to the CZ75, the SIG P226, and even later designs trace conceptual lineage to the innovations perfected in the high power. Some historians argue that the pistol should be credited as much to Save, or sometimes anglicized as Save or Sive, as to Browning, given how much posthumous engineering work Sive performed. The record supports an acknowledgement that Browning's concept and Sive's finishing engineering together produced a timeless design.
Production of the original Browning high power at FN continued for decades. It remained in continuous production until Browning announced the end of production in 2018, closing one of the longest runs in handgun history. A modernized variant reappeared in 2022 under new corporate stewardship with different internals, but the original combination of Browning's tilting barrel system and Save's double-stack magazine had already driven half a century of pistol design. So return to that Herstal workbench on November 26, 1926. Browning dead, a half-finished pistol before him, a problem incomplete.
He could not have predicted that a Belgian engineer would spend years finishing his work, that men would later fight over the pistol made in the factory that his concept helped spawn, or that versions of the same pistol would be manufactured in the occupied plant for Germany and in Canada for the Allies. He could not have imagined that his 13-round magazine would set the benchmark for sidearm capacity for the latter part of the century. The high power was not a mythic favorite of every resistance cell, nor was it dismissed by British forces as worthless. Primary documentation rejects shriller claims on both sides. The verifiable facts are powerful and precise. The high power was the first widely successful high-capacity military pistol, the practical model for modern combat handguns, and the preferred sidearm of many special forces units and clandestine operators who recognized that extra rounds could make the difference between life and death. Browning died with the pistol incomplete. Save finished the job. Canadian industry mass manufactured it. British commandos carried it into operations. 93 nations adopted it. Documents and production figures back up every step of this chain. What began as a workshop sketch became the mechanical ancestor of almost every modern service pistol, an innovation born of two designers, realized by engineers across continents, and forged in the crucible of global war. That is not a myth. That is documented history.